Welcome to a read along with Dr. Pal in the book Discrete Perspectives in Mathematics. This is section 218, entitled Complements and Duality. If we take two subsets of a power set, look at their codes, and we're using this arrow as meaning subset of, and we notice right here that wherever we have ones down here, we have ones up here, then we know that, yes, it is a subset of it, because whatever in this subset is in this one. We can also look at the same idea by the zeros. If there's zeros up here, then there's definitely zeros down here. It's equivalent. If there's ones down here, there's ones up here. It's the same thing as saying if there's zeros up here, then there's zeros down here. Now that kind of motivates a definition, namely the complement. The complement of a set, that means that we're going to be, every time we see a zero, we switch it to a one. Every time we see a one, we switch it to a zero. And we're going to have a notation for it. Put a little C, superscript right above it. So for instance, this is B complement. Let's compare it to B. Here's B, and notice how we have a zero here and a zero here. We're going to switch to ones. They're ones, and everything else is zero. That's B complement. Likewise, this is A complement. Remember, for A, you had a one here and a one here. Well, it's been exactly switched. Notice that exactly when we have ones here, that's exactly when we have ones here. So when we have ones here, then we have ones here. So we actually have that this is a subset of that. So B complement being a subset of A complement is the exact same as saying that A is a subset of B. The exact same idea. These two ideas are equivalent. Other types of equivalences arise when we switch zeros and ones, especially when we want to look at unions and intersections. All right. So think about unions as collecting ones down chutes, right? Well, collecting ones down chutes is the same thing as looking where you have zeros being the same. So, or matching zeros. So collecting ones is the exact same thing as matching zeros. Well, we can rephrase that in terms of complements. Matching zeros in the complements is like matching ones. Well, matching ones is like intersecting. So intersecting the complements is a lot like unioning the actual sets, except when we intersect them, we're still in complement land, and we have to take the complement back to get to the union. So what does that tell us? That tells us that the complement of the union is actually equal to the intersection of the complements. And remember how we saw above right there that taking complements actually switched the directions of these arrows. Like A was a subset of B, and then B complement ended up being a subset of A complement. So what we just saw as well is that these two guys turn around, like unions change to intersections and vice versa. So what we end up seeing is by taking the complements of everything in the power set, we've actually turned the whole power set upside down. We switched all the directions of the arrows, the intersections, the unions, the inclusions, and whatever else is just completely backwards. So we call it a dual picture of the post set. So we look at the post set, but then we just switch all the arrows. Because the unions and the intersections are actually determined exactly by the idea of being a subset of. So, or arrow. It's kind of like a minimality or a maximality idea associated with arrows, unions, intersections. So really just all you have to do is look at the same post set and just switch all the arrows, and that's a dual picture. The dual picture of it, and we can get that just by taking the complements of all the subsets, and everything just kind of turns around. So in summary, what we actually have is De Morgan's laws, which we kind of saw illustrations of why they worked and how. So when we take complements, it just switches things around. So this is not really, it's kind of an arrow reversing property instead of an arrow preserving. So you can almost think of it as an anti-map, if you will. Taking complements, see what happened before. It was the opposite after the complements. So think of the complement thing as a bar. It's like the opposite. Thanks for watching.